Hey YouTube, welcome back. Today we continue our series in design YouTube. Today we will talk about the video transcoding architecture. Specifically, we talk about the preprocessor component. In the previous video, we talked about the directed acyclic graph, and today we will talk about the architecture of the video transcoding. So let's just start to get right into it. So let's start. So we have today we want to talk about the video transcoding architecture and today we specifically talk about the let me just no delete that. Today we mainly talk about the preprocessor. Okay, so preprocessor. Okay, so before talking about the preprocessor, I just need to talk about what is the video transcoding architecture. So the purpose, the purposed video transcoding architecture, the leverage the cloud service, as I will going to show you. The architecture has 6 main components. We have a preprocessor, we have DAG schedule, we have a resource manager, we have task workers, and we have temporary storage and encoded video. As the output, let us to take a close look in each component. So let's just try to make the architecture, how the architecture works. So first of all, we have here. Oh no, make it really small. Yeah. So we have here the preprocessor. The preprocessor, and after that we have the DAG schedule. And after that we have let me just take it like that. Yeah, after that we have the resource manager, and after that we have the task workers, and after that we have the encoded video, the end result. And we have something also that we need to talk about. Let's just take this one and just okay. We have also we have something called the temporary storage, and it will goes like that. And temporary storage. Okay. So let's just make this quite wider and it's fetched from the task worker. So today we will focus on this one. So let's just make it, give it a color. I just gonna give it this one, and also let's give the okay. So the preprocessor, um, the preprocessor has four responsibilities. First of all, it's responsible for the video splitting. So as we said before, when you have a quiet video and like you are as a user here, we want to watch this video or like stream this video, what happens underneath that? The video is being split into small chunks, and each chunks be down copy to your machine, and you watch this specific chunk. So if you so you don't have to wait for the full video to be downloaded. So you can just watch each chunk by when in the meanwhile the other chunks are being loaded. So it makes sure that it improves the latency and gives better user experience. So because of that, we need the splitting. So the preprocessor, it's responsible for the splitting the videos, and the video streams is split or further split into small group of pictures called GOP, so group of pictures. And the group of pictures is a frames arranged in a specific order. Each chunk is an independently playable unit, usually a few seconds in length. Okay. The second thing it's responsible for too is that it's the same old mobile devices or browsers might not support video splitting. So the preprocessor split videos by group of pictures of alignment for all the clients. It makes sure that all the versions of all the clients can split it makes sure that the splitting process for all clients works perfectly for each clients, depends on, like, regardless of their mobile version or of their web browser version. The third thing that we have something called the DAG generation. So the process generates DAG based on configuration files, and on configuration files client programs write. Okay, so for example, the process generates DAG based on configuration files the client programs write. So for example, a simplified way, we have, let's just have here, let's just have make it white. We have download, and this download script has been written by the client. For example, okay, and we have here, it will be transcode. So to simplify this section is that it's like the DAG representation, which has basically two nodes, as you can see. This DAG representation is generated from two configuration files. Like for example, you have like, you know, this type of, like, you have no, make it small. I guess in the base, in interviews, you don't have to know all of that, but I'm saying because you should know it, because yeah. So for example, you know, like you have task 1, and it's an object, and inside this object you have for example the name of the actual file. You have the type, you have the URL, you have some basic information. So the main goal, the third one, is that it helps in the DAG generation. So the process generate DAG based on config file. So this one, it's responsible to generate a DAG generation, and you should watch the previous video that we talked about the DAG model, the directed acyclic graph. So based on the files that the client has, it generates a DAG process for that. The last thing that we have cache data. So basically, if you can see, we have something called temporary storage. So the cache data, the preprocessor is cache for segment videos. For better reliability, the preprocessor stores group of pictures, which like you can say, yeah, group of pictures or GOP, and metadata in the temporary storage. If videos encoding fails, the system could use the persisted data for retry operation. And yeah, that's it. It was a quite quick video, and I guess we have 1, 2, 3, 4, 5 more videos talking about this specific components. I guess and all of them are pretty interesting ones. We have and maybe you have how many videos are left? Check. We have 5 videos and 6, 7, and 8, 9. Oh, it's a lot. Oh, 10, 11, and 12. We have 13 videos left. Okay, it will be too much. It will be big serious. It will be big serious, but believe me, it will be worth it. So yeah, that's it for this video, and I hope my description was quite good. If you like my content, make sure to subscribe and hit the notification bell so you'll never miss a video, and see you in future problems.